Hi everyone, this is the next video on simultaneous equations. We're going to be looking at using the discriminant to help with what we've covered so far. So the graph of a linear equation and the graph of a quadratic equation can either intersect at 2 points, intersect at 1 point, and not intersect. So when we have substituted in the curve and the linear, we can use the discriminant of the resulting quadratic equation to determine the number of points of intersection. So that quadratic that is formed after the substitution, if the discriminant is greater than 0, then we know it has 2 points of intersection. If the discriminant of that resulting quadratic is equal to 0, then we know that there is 1 point of intersection. And if the discriminant of the resulting quadratic is less than 0, then we know there are no points of intersection. So let's have a look how this all works then. So we have y is equal to x squared here, and we have 3 separate lines. Let's have a look at the purple line first. It looks like it intersects at the bottom here, and y is equal to minus x minus 0.25. So when we start off, we would equal them to each other because they're both equal to y, rearrange, and this is the resulting quadratic I'm talking about. So from here, we could calculate the discriminant. Go ahead and pause the video if you like and calculate it. The discriminant is equal to 0. So we know straight away that there is 1 point of intersection. And we can see that from the graph anyway. You would also be able to see that there is 1 point of intersection for when you solve this, because when you solve this, you are going to get a repeated root. So there's only going to be one solution. Let's look at the blue line, y is equal to minus x plus 12. We've got 2 points of intersection from the graph. So again, if we equate the curve and the line to each other and rearrange, we would get this resulting quadratic. And from here, you can calculate the discriminant and it will be greater than 0, which shows that there should be 2 points of intersection. Again, if you factorise this, you would have 2 different solutions, and that would show that there are 2 distinct roots. Here we've got the line, the green line, y is equal to minus x minus 4. We would equate them, rearrange, and if we find the discriminant of this, it is going to be less than 0. If we were to solve this quadratic, we wouldn't be able to factorise. If you tried solving it on your calculator, it would show no real solutions. And therefore, it corresponds with the fact that on the diagram, the green line and the red line do not cross. So there are no points of intersection. Let's have a look at some examples then of how we can use this knowledge. So we've got to show that question. Show that the line y is equal to x minus 4 is a tangent to the curve x squared plus y squared is equal to 8. Well, this is a circle and this is a line. So we've got to show that this line just touches the circle, because that is what a tangent does. It touches a curve at 1 point. Well, if it's only touching at 1 point, then we know that the discriminant of the resulting quadratic is going to be equal to 0. So I'm going to be using that information when I get to that point and almost calculating the discriminant and showing that it's equal to 0. Therefore, this line is a tangent. So let's start, first of all, by substituting equation 1 into equation 2. So I'll have x squared plus x minus 4 squared equals 8. let's expand. So x squared plus x squared minus 8x plus 16. And I'll move the 8 over, minus 8 is equal to 0. Let's collect like terms. So 2x squared minus 8x, this will be 8 is equal to 0. You can work from here. I'm just going to go ahead and divide by 2, like so. Now this is a resulting quadratic, so I'm going to calculate the discriminant, and it should be equal to 0. So b is minus 4, so minus 4 squared minus 4 times by a, which is 1, times by c, which is 4. Well, minus 4 squared is 16, and then we've got 4 multiplied by 1 multiplied by 4, which is 16. And that equals 0. So as it's a show that question, let's just tie it together. And I'm going to say, therefore, y equals x minus 4 is a tangent as b squared minus 4ac is equal to 0. And I'm just going to leave it like that. You can go on and say, therefore, there is one point of intersection if you like, but anything along those lines would be fine. Let's move on to another example. Find the range of values for k for which y is equal to 2x plus k and x squared plus y squared is equal to 4 do not intersect. So the line and the circle do not intersect. So the discriminant of the resulting quadratic is going to be less than 0. And we're not asked to show that, we're asked to find the range of values for k. So we're actually going to be solving the quadratic inequality when we get to this stage and finding the range of values. So let's start by substituting. Sub equation 1 into equation 2. So I'll have x squared plus 2x plus k squared is equal to 4. X squared plus, expanding this, 4x squared. You would almost get 2xk and 2 lots of that, but I'm going to write it as 2kx, and again you've got 2 lots, so it's going to be 4kx plus k squared, and I'll move the 4 over, minus 4 is equal to 0. Let's combine the x squared terms, and I'm going to put a bracket around the k squared minus 4, because now it's in the form of ax squared plus bx plus c. So now I'm going to use the discriminant and the fact that we know that the discriminant is less than 0. So b squared is going to be 4k squared minus 4 multiplied by 5 multiplied by k squared minus 4, and that's less than 0. So I'll have 16k squared minus, now this is going to be 20, and then we'll write that. I'm going to expand this out in the next step. So I'll have 20k squared minus 80, and then I'm going to multiply by the minus. So minus 20k squared plus 80. Now I'm going to combine the k squareds together, so I'll have minus 4k squared plus 80 is less than 0. I'm at a stage now where I can go ahead and solve this inequality, so I'm actually going to look at the quadratic and solve that. I'll move the 80 over and divide by minus 4. Now I've got a squared, so I'm going to square root both sides, and because I'm square rooting, I'm initiating it, so I'm going to have a positive and negative value. Now you can work with this, or you can simplify root 20 to 2 root 5. Now let's sketch the quadratic. I've got a negative coefficient of k squared, so it's going to be an upside down U shape, and it's going to be pretty symmetrical considering the solutions. So something like that, minus 2 root 5 and 2 root 5 over here. Now let's look at what we need. Well, we need a less than 0, so anything below the x-axis. So we're looking at these values here and these values here. So therefore, k can be less than minus 2/5, or k can be greater than 2/5. And again, you can leave it as root 20 if you like. Let's have a look at a final example. So we've got to find the range of values of k for which kx plus y equals 3 meets x squared plus y squared equals 5 at 2 distinct points. Now this is a circle, this is a line, so we're going to have 2 points of intersection. That means the discriminant of the resulting quadratic is going to be greater than 0. So equation 1, equation 2. I've got to rearrange equation 1 first. So I'll make y the subject and move the kx over. Then I'm going to substitute it into equation 2. So x squared plus 3 minus kx squared is equal to 5. Let's expand this bracket. So I'll have 9 minus, it'll be 3kx and minus 3kx, and I'll have 2 lots of it, so 6kx, and then plus k squared x squared. And let's minus the 5. So I'll just rewrite that without the brackets, and then we'll be looking at collecting like terms. So I want to collect the x squared terms together. Think about it as one lot of x squared and k squared lots of x squared. So I'm actually going to factor out the x squared, and I'll have 1 plus k squared as the coefficient. So that's actually going to be the a part. Then I'll have minus 6kx, and minus 6k is going to be the b. And then 9 minus 5 is going to be 4, and 4 is the constant. So now I'm going to use the discriminant and the fact that I know it's going to be greater than 0. So here I've got b squared minus 6k squared, then I'll have minus 4 multiplied by a multiplied by 4. And that's going to be greater than 0. Minus 6k squared is 36k squared, minus, I've got a 4 multiplied by a 4, so 16, 1 plus k squared, and then that's greater than 0. Just be careful when we're simplifying, we don't want to jump too many steps. So now I'm going to expand the bracket here. So 16 plus 16k squared. And then I'm going to have a minus 16 when I multiply by minus 1, and a minus 16k squared. Now I'm going to collect the k squareds together. So I'll have 20k squared minus 16 is greater than 0. And I'm at a point where I can solve this now. So I'll move the 16 over, divide by 20, I've lost my k squareds for some reason. And now I'm going to square root both sides, and I'll have a positive and a negative solution. Now you can leave your answer like that. I'm going to go ahead and simplify a little bit. So root 16 we know is 4, so I'll have 4 over root 20. And again, you can keep it like this. I'm going to use knowledge from chapter 1 and actually rationalise the denominator. And when you rationalise the denominator, you should get 2 root 5 over 5. And obviously a positive version and a negative version. So let's look at sketching the quadratic. The quadratic was here, so it's a positive k squared, and I've got these two as the roots, so it's going to be symmetrical again. So this is going to be minus 2 root 5 over 5, and this one is 2 root 5 over 5. Now I want greater than 0, so it's going to be these values and these values. So my answer is going to be k is less than minus 2 root 5 over 5, or k is greater than 2 root 5 over 5. That was quite a large example, so feel free to pause and rewind if you need to go over some of the steps again. Now I'd like everyone to pause the video and have a go at exercise 3C, page 45, questions 4, 7, 8 and 9. Now in this video we are going to move on to inequalities and graphs. So as you will have seen already, we've been combining our knowledge of simultaneous equations and inequalities all together, and this is actually doing very similar but with the graphical methods as well. So you may be asked to interpret graphically the solutions to inequalities by considering the graphs of functions that are related to them. So here we have the blue curve, which is f of x, or y is equal to f of x, and here we have the red curve, which is g of x, so y is equal to g of x. If we look at this part, the values of x for which the curve y is equal to f of x is below the curve of y is equal to g of x satisfy the inequality f of x is less than g of x. So basically we're looking at when the curve of y equals to f of x is less than y is equal to g of x, and it is below the red curve here. So any part between this point and this point, which we would be able to find by solving simultaneous equations. The next one, the values of x for which the curve y is equal to f of x is above the curve y is equal to g of x. Satisfy the inequality f of x is greater than g of x. So when is the blue curve above the red curve? Well, it is here. So from this point below and from this point above. Let's have a look at a few examples then of how to use this knowledge. So L1 has equation y is equal to 12 plus 4x, and L2 has equation y is equal to x squared. So you can see which one's which below because it says there is a sketch on the same axes. Part A, we've got to find the coordinates of P1 and P2, so the points of intersection. We know how to do that, it's by solving simultaneous equations. So let's go ahead and do that. Both functions are equal to y, so I'm going to equal them to each other. So x squared is equal to 12 plus 4x. Rearrange so everything's on one side. And I've got this quadratic. Now I'm going to solve this quadratic by factorising, so I'll have x minus 6 and x plus 2. And then I'm going to have x is equal to 6 and x is equal to minus 2. Now it's asking for the points of intersection, so I do need to find the y values as well. So when x is equal to 6, I could use this one over here. Y is equal to x squared, so y is equal to 6 squared, which is 36. Now let's have a look at this one. X is equal to minus 2, so y is going to be equal to minus 2 squared, which is equal to 4. So let's have a think about which one's going to be P1 and P2. Well, P1 is going to be a positive x value, so P1 is equal to 6 and 36, and P2 is equal to minus 2 and 4. Let's move on to part B then. It says, hence write down the solution of the inequality 12 plus 4x is greater than x squared. Well, 12 plus 4x is L1, line 1, the black line, and x squared is L2, the red line. So it's asking us really when the graph of L1, this line, is above the graph of L2. Well, it's above the graph of L2 between these two values. Sometimes it makes sense going from left to right. If it's not making sense for you going from left to right, let's look at it right to left. So x squared is less than 12 plus 4x. That means when is x squared less than this line? Or when is this red curve below the black line? Well, it's below the black line here, between this point and this point. And you might feel this is a little bit similar to when we are solving inequalities and we're using the sketch to work out whether it's above or below. So what is the x value of P2? Well, the x value of P2 is minus 2. And the x value of P1 is 6. Just check the signs. We do want just a normal sign, not an equal to. So that is going to be the solution to the inequality. Okay? Let's have a look at another example. So given f of x is equal to x squared minus 6x and g of x is equal to x plus 8, sketch the graphs and find the set of values for x for which f of x is less than or equal to g of x. So there seems to be a lot going on when you first read it. Let's break it down. It asks for a sketch, so that's going to be step 1. And then it asks to find the set of values of x. Well, we can only find the set of values for x when we have found the points of intersection, or maybe just the x values at the point of intersection. And then 3 is going to be find the set of values. So let's go with step 1. I'll circle it twice. Let's do the sketch. Now, we've got y, we can read this as y is equal to x squared minus 6x. Well, we might want to think about the root, so where it crosses the x-axis. And it crosses the x-axis when y is equal to 0. So I'm going to write this as x squared minus 6x is equal to 0. And then I'm just going to factor out the x. So I'm going to have x minus 6 there as well. So x is either going to be equal to 0 or x is going to be equal to 6. So our sketch of f of x is going to look something like that. I'm a little bit tilted, but you will get the gist. Now I'm going to look at sketching g of x, and I'll do it in a different colour. X plus 8. Y is equal to x plus 8. That means it crosses the y-axis at 8, and the gradient is a positive gradient, and it's 1. So if it's crossing at 8, it's also crossing at minus 8 on the x-axis. So something like that. And I'm just going to extend this, because if this quadratic was extended, there would be another point of intersection there. So now moving on to step 2, and I'm working out the points of intersection. If you wanted as well, before we move on, let's just label parts of that sketch. So I'm going to substitute, and because these are both equal to y, I can equal them to each other. So x squared minus 6x is equal to x plus 8. Let's rearrange, so I'll have x squared minus 6x minus x minus 8 is equal to 0. Let's collect those x terms together. And now I'm going to factorise. So I'll have minus 8 in one bracket, x minus 8, and x plus 1 in another bracket. So x is equal to 8, or x is equal to minus 1. Now it's not asked us to find the points of intersection. It just goes from the sketch to find the set of values of x for which this is correct. So I don't actually need to find the corresponding y values. So I know that this point here, x is equal to minus 1, and this point here, x is equal to 8. So let me just move that 6, because it looks like that is 6 and it's not. So I'll put 6 here on the other side. So let's move on to step 3. And we are finding these set of values. So we're working out when f of x is less than or equal to g of x. Well, let's label the graph so it's easier to see. F of x was the curve, so g of x is the line. And we want to know when f of x is less than or equal to g of x. So it is less than or equal to g of x here. So it is between two x values underneath. So we can write that as, well, remember this is minus 1. We're going to use the equal to signs because that is what is given in the question. And the next value is 8. So this inequality is satisfied between x is greater than or equal to minus 1 and x is less than or equal to 8. Let's go on to example 3. So the graph shows f of x is equal to 2 over x. So this is going to be f of x here. And g of x is equal to 3. So this is going to be g of x. Now we've got to find the set of values where f of x is greater than g of x. So f of x is greater than g of x here. But we need to work out what this value is so we know what the set of values will be from there. So the way we could work that out is by simultaneous equations. So I'm going to have y is equal to 2 over x. I'm just going to write them as y, and y is equal to 3. So I'm going to equate these. So let's have 3 is equal to 2 over x. I'm going to multiply by x on both sides. So I'll have 3x is equal to 2. And then I'll divide by 3 on both sides. So x is equal to 2 over 3. So I actually know what this value is here. This x value is 2/3. Okay, x is equal to 2/3. So really, I can actually complete this then. So for f of x is greater than g of x, I didn't need that little bracket there, I'm going to be going from 2/3 and below. The values are getting lower. So x is less than 2/3. So that shows those values there. Let's have a look at a final example. L1 has equation 2y plus 3x is equal to 6. This is L1 here, the red line. And L2 has equation x minus y is equal to 5, which is this black line here. We've got to find the coordinates of P, the point of intersection. So this is P here, and we've got to find the coordinates. Because it's saying coordinates, it wants x and y value. So let's start by doing that first. Now I am going to label that 2, label that 1. I'm actually going to do a substitution. So I'm going to rearrange equation 2, and I'll make x the subject. So it'll be x is equal to 5 plus y. Now you could have made y the subject, or you didn't even have to do a substitution. You could have done an elimination because they are both linear. So let's now sub into equation 1. So wherever I see an x, I'm putting 5 plus y. So 2y plus 3 multiplied by 5 plus y is equal to 6. Let's expand. So 2y plus 15 plus 3y minus 6 is equal to 0. So then I'm going to have 5y is equal to, well, 15 minus 6 is 9, and I'm going to move it over there. So minus 9. So y is going to be equal to minus 9 over 5. Now you can leave it like that, but minus 9 over 5 is minus 1.8. Now I'm going to find what x is. So when y is minus 9 over 5, x is equal to 5 plus minus 9 over 5. And that is going to become 16 over 5. So again, you can leave it in fraction form, or if you like, x is equal to 3.2. So I have the coordinates of P. Let's just write it out. So therefore P is equal to 16 over 5 minus 9 over 5. I'm keeping it as fractions. So part B, hence write down the solution to the inequality 2y plus 3x is greater than x minus y. So I'll do it over here. So we're looking at when line 1 here is above line 2. and L1 is above line 2 here. So from point P that way. Sometimes it is a little bit harder to see because it is on the side. It's not a horizontal line, this. But just try and think it's below the line here and it's above the line here, and we want line 1 to be greater than line 2. So we are going to have, well, whatever that x value was, the x value is 16 over 5. So x is going to be less than 16 over 5. And again, you can have the decimal here. An equivalent of that is absolutely fine. I've covered a few examples there, so I'd like you to pause the video and have a go at exercise 3F, page 52, questions 2 and 3. This will be the end of the video.